and close. On the test that you'll take Thursday after you get back from the break, I have not looked at the test recently, but from memory, I'm 95% confident there's one or two problems that are going to deal with absolute maximum. And to successfully solve the problem, as always, you can't just do steps. You have to read the problem, understand what it's saying, and then apply the min-max theorem. So I'll pay extra credit for every person in the room who can raise their hand and tell me, what would I write as the min-max theorem as the theorem applies to this problem? I'll look at like, what the heck is the min-max theorem?
Are you asking what the theorem is? Like,
I want to know how to write the theorem specifically for this problem. How to write the theorem specifically for this problem. So, Callie?
So f of x is greatest either at the start, -2, or the end.
So pause for 1 second. You are doing really well. So f of x. Question for everybody. When I say f of x is greatest, am I talking, hands up, am I talking about the x coordinate, the y coordinate, both? Hands, come on. When I say f of x is greatest, am I talking about the x coordinate, the y coordinate, both? Key to the AP test is keeping that straight. Whenever a student gets mixed up, it always leads to all kinds of problems. How many knew it was the y value? Good point for Colbert. So the y value of f is going to be greatest. So f of x is greatest at x equal -2. That's, as Callie said, that's the beginning x coordinate. Keep going, Callie. Or x equal 4, which is the final x coordinate.
Or somewhere in the middle where f prime of x is 0 or under 5.
And I'm going to alter that just a little bit this time. There's different ways you can think of the theorem. They all work. I'm going to say it's a place where f has a relative max. To start this problem or something similar on the test, that's where you need to begin. 2 points for Callie. Anybody else? And then, look, here's the key. I was helping someone with, not this one, but some other problem dealing with absolute max after school. And once I could get the student, it was Cassidy Nelson actually, once I could get Cassidy to, like, on her own without me giving any prompting, like, apply the theorem to this problem, I think she won't ever forget. But I've seen lots of students really struggle with these. For some reason, it just doesn't stick. So that's why I want you to be able to say to me, like, how do we take this information and start applying it to this problem? Like, what does this mean? Like, how do you use this to solve the problem? For someone to volunteer. Like, this is the key. You have to follow this theorem. But how do you use this theorem to answer the question they're asking for? Parker.
So, well, first of all, I think you're going to need to find the relative max just to double check, because those might be your absolute maxes. You're just not sure yet. So you need to do a derivative first.
Pause right there for 1 second. 2 points. Something I really will push you all to do. We're headed towards a sign chart because we have no way to graph anything. Don't ever make a sign chart until you make a Danica's chart first. That also happened the other day, and I don't remember which period it was, but the entire class was completely headed down the wrong track. Like, they were heading towards one of the answers that is wrong because they failed to make a Danica's chart to match up with their sign chart. So 2 for Parker. Originally, if you know what Danica's chart I need, because Parker's on the right track, he's like, hey, if we're supposed to find where f is greatest, that might be where f has a relative max. So I need a Danica's chart to understand how to figure out where f has a relative max. Hands. Uncomfortable silence, sink in for a minute. Savannah's kind of like this, and she's back to this. Let's go, Andrew.
So the increasing and decreasing on the f is when f prime is positive.
That is exactly the Danica's chart that you should be thinking of, because f will have a relative max when f changes from increase to decrease, which will occur exactly at the same x coordinates where f prime changes positive to negative. That's the Danica's chart you need. Who had their hand raised and would have said that? 2 points, 3 friend. We want to talk about it. Cool. So Parker said find f prime. That makes good sense. So f prime is going to be Parker.
So what I did on this question is I didn't do even a sign chart or Danica's chart. I just did it algebraically because I got my zeros when I was going to originally do a sign chart, but then I decided I just got my zeros there, and I knew what it was going to easily be, so I just plugged it into the original equation.
So what zeros of what?
So the zeros, so 3x squared minus 6x. So you're going to get your factored form of that, which is going to be pull 3 and an x out of it. So you're going to get 3x and an x minus 3.
2.
And you can just see your zeros, or 2, sorry. You can just see your zeros right there, and then I just plugged it into the original problem. Didn't even worry about Danica's chart or an original.
That's actually okay.
Chart.
I just didn't think of it. It's actually just fine to do that. So Parker figured out that f prime of x is equal to 0 at x equals 0 and x equal 2. This is a totally valid way to solve the problem. I just didn't think of it. It's totally valid. Wave at me if you want more to talk about this. So he took the route Callie was going, which was instead of looking for f has a relative max, he said, oh, let's just go look where f prime is equal to 0, or where f prime is undefined. So he's discovered this is where f prime is going to equal 0. So he said what he did, but I want all of you to be able to say what he did. So what did he do after this? Hans? What did he do from here? This is where if it doesn't click, like if it doesn't click in your brain, you go, oh, that makes sense. Then we got to talk some more. But for Julie. So tell me exactly what to write, Julia. Oh, make sure it's an equation.
Okay, f of 0, f prime of 0 equals 3 times 0, parentheses 0 minus 2.
Now, hold on 1 second, Julia. Hold on 1 second. You're doing just fine. Okay, look. Julia gets the huge bonus for asking a really good, for actually doing something that's really helpful. So it's a mistake, but I need everybody else to see the mistake. It's okay. Lots of people do that, I promise. This is really common. So what's wrong here? But it is very common that people, like, everybody does this on the test. Like, what's wrong here, Savannah?
Should plug it into the wrong equation, right? So
Just tell me what you would write.
I would do f of 0 equals 0 cubed minus 3 0 squared. Plus sign plus 12.
Pause there for 1 second. So raise your hand, please, if prior to Savannah saying it, you knew to write this. Point 2 for Savannah. Answer this question. Hands up. What number is going to go here? Hands up. Come on. What number is going to go here? What number belongs here? Nick?
0.
How many knew it? 2 for Nick. Hands up again. What does this 0 represent? Come on. What is this 0 representing? Julia, please.
It's a y value
On which graph?
on the
Perfect. So this is a y value on f prime. So what is this on the graph of f? Just a slope. So plugging the 0 into this doesn't really help us. It just confirms what we already knew, that at x equals 0, the slope of f does have a value of 0. So f might look like this, f might look like this, or this would be most common. But that doesn't help us figure out whether or not that's a place where f is greatest. It just tells us the slope of f. Does that make sense? This is 12. Raise your hand, please. What does the 12 mean? Hands, come on. What is the 12 representing? You can't succeed in this class if you can't keep track of what the numbers mean. You can't just find the numbers. So what does the 12 mean? Let's go, Sarah.
The y value
Of
f.
of f. And which y value of f? Because f has lots of them.
F is 0.
Good. So this means that on the graph of f, at x equals 0, we have a point. So if I were trying to draw the graph of f, I could say, on the graph of f, at x equals 0, there's a point whose y-coordinate is 12. That's what I know so far from this green equation. How many knew it? 0.2%. It really is absolutely critical that you do not mix up when to use f versus when to use f prime. They want me to talk more. Julia, does that make sense? Good work. I need some feedback from all of you. As a teacher, I try really hard to never make the assumption that what I do is best, because it's not best if it doesn't help you. Okay? So I've tried hard from the beginning of the year to promote this idea that making a mistake is nothing to worry about. It's just like we got to learn from the mistake. And I'm trying as hard as I can to not let anyone feel awkward if they do make a mistake, so you're all comfortable just to keep trying. So Julia gets a double bonus today for being such a good sport. My question is this, okay? When I do something like that, like Julia gives me an answer, I write it down, and there's no way to proceed without telling you that it was incorrect. But I kind of want to make a big deal about it in a way I hope that's not making you feel bad. You know what I mean? Does that make sense? So that's why I pay the ticket for the really valuable mistakes, in my opinion. Give me feedback. You're looking like, what are you talking about? Give me feedback. If you feel like that little process that I do is like really, really helpful, you're going to do this. You're like, please don't ever do that again. I hate when you do that. Show me. Just give me your vote. Do you feel like calling attention to the mistake by paying a lot of extra credit so we can talk about it in a way that hopefully doesn't feel threatening or anything? You're like, hey, that's really helpful. I like when we bring that up. You're going to vote this. You're like, I hate when you do that. Please don't ever do that. Show me. Thank you. Good. So now what do we do? More hands. Come on. What do we do? Have to think with me. There's lots of studies shown that unless you do a lot of self-quizzing prior to a test, you're really not going to be ready for the test. That's why I try to do lots of interactive quizzing. Let's go, Matt.
So now that we have the y value, the y coordinate for x equals 0, we have to find the y coordinates for the other points where the slope is 0.
Just tell me exactly what to write.
So we're going to solve for x equals 2 now. So
Tell me
we're
what to
going
write.
to
You're
do
doing
f of 2 is equal to 2 cubed minus 3 times 2 squared plus 12.
So that's 8.
8 minus 12 plus 12.
So minus, oh, so it's just 8, right? So how many knew to write this down? 0.2 for Matt. There's something I'm doing here that I make a big deal of. 1 second, Parker. I'll pay you if you can notice what I'm doing here that I say over and over again you should do as well to prevent errors. It's just a notational thing that I found that if you don't do this, you will make mistakes. I've seen it happen over and over again. Devin?
When you plug in the x value, you put parentheses around it.
perfect, always. If they're positive values, it's not typically as risky, but as soon as negatives start getting involved, without the parentheses, people make errors. How many knew that? Point for Devin. So what does this mean in orange? Hands, come on. What does the orange mean? What does the orange mean? For Nathan.
It's when x is equal to 2, when x is equal to 2, and y is equal to 8.
On which graph?
On the x.
Good. So here in my little sketch, here's the F graph. I know that when x is 0, y is 12. Now I know that when x is 2, y has a value of 8. How many knew that? Point 2 for Nathan. So now what do we do? Okay. Now what do we do? Let's go bright.
Take which one's higher. We have more.
So are you ready to choose an answer, Bryce?
Yeah.
So what would be the answer? Which letter would be the answer? So raise your hand if you agree. Show me your hand. 2 points, 3 for Bryce. You all said this was a good method when I asked for it, so we'll keep doing it. Yeah, common mistake. It's a really good mistake to notice that. Good part.
You have to look at the F because 4 is not just through F, 4 is the F.
Who knows the error?
Oh, yeah.
Hands, come on. Who knows the mistake?
For the sign chart, we did-
And as I tell you over and over again, the AP test writers do not create random answers. They always make answers that are traps. Like they're trying to get you to make a mistake so you step in the trap. Maya.
Is it that we don't know if it's greater? Well, let me restart. We don't know if that is a relative or local tax.
That's true.
I mean a global or local.
True. So tell me what you want to do. Like I think you've got the right idea. Just tell me what you want to do.
We need to plug in the beginning and end values to the first equation.
There we go. The theorem says f is going to be greatest at x equal -2, x equal 4, or where f prime has a value 0. So we've checked where f prime is 0, but we didn't check the start point and the end point.
Yeah.
How many knew it? 2 points, 3 for Maya. Please, Elena.
So what I did for this is I made a sign pattern chart of f prime, and I saw that 2 is going to be a relative minimum. So I did it even. Is that okay?
Oh, yes.
That's the benefit of the sign chart.
Yes, listen to Elena. Listen, hey. No, it's perfect. And Matt said it as well. It's the whole idea of, and there's really, I wouldn't say one way is necessarily better than the other. They're just two different methods. So if you make a sign chart of f prime, you actually discover, in fact, let's do that really quick. It'll be better to talk about it. So 1 second. So 3x, copy this over. Okay, so we figured out that f prime is this formula. Three x multiplied by x subtract 2. So if I make a sign chart, start at x equal -2 through x equal 4, I'm making a sign chart of f prime. My two factors of f prime are these. Okay. The whole point of making the sign chart of f prime is so you can draw a reasonably correct picture of what the graph of f would look like. Like I don't see any value to doing, well, I guess some people can just do it in their head. But anyway, I look at f prime and I'm like, oh, I can now draw what f would look like. Raise your hand if you can look at this f prime sign chart and draw what f will look like. Show me your hand. So who can tell me how to draw what f's going to look like? So Jane?
You start like lower, I guess, and you go increase, then a 0, then down, and decrease, and 1 0, up.
How many knew that? 0.2 for Jane. Okay, so here's Elena's, what Elena did works really well. Based on this picture of f, please raise your hand if you can tell me. The min-max theorem said, okay, the greatest point on f is going to be at the beginning, the end, or somewhere where f prime is 0. But by making a sign chart of f prime, we get a clearer picture of where f is greatest. So hands up, at what x coordinates can f be greatest? Based on our sign chart work, at what x coordinates can f be greatest? Like it? 4. What would be the other place where it could be greatest? So definitely can be greatest at 4. Also 0. So I don't really have to check this endpoint. I do not have to check this spot because, as Elena said, that's a relative min on f. I still have to check these two. So I have to compare the y coordinate at x equals 0, which we did find already is 12. I have to compare that y coordinate to what the y coordinate will be when x is 4. So I'd have to go find f of 4. How many knew this before Micah said it? 0.2 for Micah. What is it? Help me. 28?
Yeah.
The correct answer is this one. Question? Please. Good question, Sarah. 3 points for that. Put down 4 for us. 5. Okay, here we go. Listen. Okay. Yeah, they test you on this all the time. Relative max and local max are exactly the same. But they will use, it just seems like every other question, they just change the wording, but they do mean the same thing. So relative max, local max are exactly the same. Hands up if you can answer this. What's the difference between a relative max and a relative extrema? And what's the difference between relative max and relative extrema?
Extreme would be relative.
Yeah, perfect. So when they say relative extrema, it's like saying relative minimum or relative maximum. Or they could say local extrema would be, again, local minimum or local maximum. 2 points for Nick. Who else knew it? Point. Okay, question? And then, okay, this is where you have to be a little more careful. So if they're asking a question about relative or local max, they always use the word relative or local. Always, without fail. But if they're asking for the highest point on some graph, they may use a whole bunch of different words. They may just say, where is f of x greatest? Or what is the absolute max of f? Or in story problems, they'll just say, when is the truck heaviest? Or when is the temperature highest? Those all refer to absolute maximum, which means look at the graph for which we are trying to find the absolute max and simply identify which y coordinate is highest. Have I answered your question? Yeah. Okay, please.
This isn't the best of some questions, but would they ever compose a question that gives you the parentheses for what it's composed in? So it's not asking for a global max, but it's asking for a local max. Well, that would just be, never mind, I just answered.
Yes, your own question.
Answered my own
2
question.
points for asking. Please.
Will they ever give you a story?
No one talks like in here. No one talks like in here. What?
Will they ever give you a story problem where you're finding the local maximum? And will they just ask for local or
But
relative?
they'll specifically use the word local or relative. Always. Yep. 2 points. Anybody else? So that's what I key on my is as I'm reading the problem, if I do not see the word local or relative, then I kind of read it again just to make sure I haven't missed the word. I'm like, oh no, this is global. They're wanting the highest. So, anybody else? Please.
Just like to be clear, if it's asking for the relative or local max, it's just asking for the high points.
Oh no, good question.
Then
Hold on.
I don't take you on that. 'Cause it's like,
Hold on, everybody look. Put down 5, that's a good question. Okay, it's on your white reference sheet. A function f has a local or relative max when that function f changes increase to decrease. That's it. It's not just a high spot somewhere. It has to be where f changes increase to decrease.
So if it's on like a -2 to 4, it would have to be 0 because it can't. 4 is an endpoint. It has to be
Correct. This is not a relative max.
Okay.
This is just the end point that could be highest, but this is not a relative max of f. Is that your question?
Yeah.
Very good. Please.
Will there ever be an instance where like it's say that a graph of f is increasing, but then it like goes flat a little bit and then it decreases? Like, would that be global or local?
I've never seen them test us on that because it does introduce ambiguity, right? Like confusion, like what am I supposed to say? So what you're saying is if the graph of f actually did this, so I've seen them give problems where f does do something like this, but I've never seen them say, okay, where's the relative max? I don't know. Here, you know? Yeah, I've never seen them do that, so I think we're okay. Good question. 2 points. Julie, please.
A local max is when it changes from increasing or when that changes from increasing to decreasing. But can't that also be a global max? Can't that happen?
It's a slight error in what you said, so I'll just say it back to you. So f, okay, quiet. So f has a local or relative max when f changes increase to decrease. But that could absolutely be the absolute max. That's what the min-max theorem is telling us. That the highest point in f is going to be either at the very beginning of f, the end of f, or where f has a relative max. So does that answer your question?
Yeah, but then like in the test, how would you know that it's a local max and not?
Oh, the way they've always asked the question is if they're asking for just where f is greatest, you don't care whether that highest point on f is occurring at a local max or at an endpoint. You just have to find it. So they don't ask you to distinguish. You just have to find it. If they're asking for relative, they'll specifically say identify the relative max, and you'll go looking for where f changes increase to decrease. And you won't worry about the endpoints. That's your question. Important. Do we know? Really good discussion. This is so that.